population standard deviation, I can't put a population standard deviation into this format, can I? I can't put one in here if there's no population standard deviation. Do you agree that these two look fairly the same setup? So if I was doing a comparison, I would say it has a confidence level T or Z to it. It has a standard deviation, population or sample. It has a square root of n, how many are in your sample. It works the same. This works the same. I use the TC for this because I do not know a population one. I only know a sample one. So therefore, I've got to follow my table 5. Table 4 is for Z. Table 5 is for T. It also has to tell me that either my population is normally distributed, or my sample is, or my sample size is greater than or equal to 30, just like it did before. So because my sample size is 36, it doesn't have to tell me that. Automatically, my sample will be approximate a normal curve. Even though your T's kind of keep going in different families of curves, they eventually come down where your Z curve is. So we fill all this in, we calculate this, and we do this. If this was a Z-score, this is your only difference right here, just this guy. I would put this in. So say my standard deviation for my population was 2.39, for instance. I would put this guy in. I would divide it by the square root of n. I would come out with my margin of error. So when I come out with my margin of error, I know the problem didn't ask this, but I thought we would put this in there at the same time. This one comes out to be 1.03. See the difference? This one's larger. This one's just going to give me a little bit more wiggle room. And in a sample, we always decide if our sample is a good representation of our population. So this little extra wiggle room will take care of that. I would do 9.75 plus or minus 1.03. And now I would get 8.72 to 10.78. Slightly wider situation. Slightly wider on my TC. This one's going to be a little bit narrower. If I put these on a number line, here's my mean in the middle. Here's your TC guy, 8.66 to 10.84. And here's my population one, 8.72 to 10.78. See? The ZC is slightly narrower. I don't need to be exact if I know more information about my population. Only when I don't know the information. Are we good with this? Can everybody do the TC part? Questions at all on the blue? No? Okay. So, how do we think and say, how do we know what's going to happen? We look at this little flow chart. And we say, how do we know which one to use, a T or a Z? A T distribution? Or a Z distribution? This is the biggest thing that you're going to have to know. Because I will give you the formulas. This is what you have to decide. So how do I decide this? This is my deciding factor. I would do my flow chart slightly different than they did theirs, but I'll go with theirs and then tell you what I would do. They say, do you know the population standard deviation? If you do, is your population or your sample normally distributed or n is greater than or equal to 30? That's a must. If that's true, you use your ZC part. Because look, you know the population standard deviation. If you do not know the population standard deviation, and you still are sure that your n is greater than or equal to 30, or you are normally distributed, you use the TC one. That's the only difference. If If I wrote this flow chart, first thing I would ask is this question. Is the population normally distributed, or n is greater than or equal to 30? If that's a yes, then I would come down here. If that's a no, I stop. I can't go any further. If that doesn't fulfill your situation, then you can't go any further. Then once you get down here, you're either using this one or you're using this one. The only really thing you have to know from this, that you have to decide. Okay? But you can kind of tell by the formulas, right? If I put these two formulas side by side, this one uses what? Population, therefore it's a Z. This one uses sample, therefore it's a T. But you know how I do your population and your sample things all the time? This is standard deviation. This is standard deviation for your sample. So it kind of gives it away, right? Kind of. So that's the only thing you have to decide. So if I asked you this, you randomly select 25 newly constructed homes, and it's 25. Always pull out your information. The sample mean, this is my X bar, is 181,000. And the population standard deviation, how do I represent population standard deviation? What symbol? The little O like this, it's called the sigma. Believe it or not, this is the capital sigma. This is the lowercase sigma. When I was first teaching this, I used to call that omega. For some reason, I thought that was omega. But that's a lowercase sigma. Then I grew up a little and read the book and figured it out. So, assuming that we get all this right, so this is your population standard deviation. So it says, assuming that you are normally distributed, they had to tell us this because why? Why did they have to tell us that? Because my sample size is less than 30. Good. So they have to tell us this or I can't use either. So which one should I use? Should I use a ZC or a TC? ZC. And if I looked at both of my formulas, here's my deciding factor right here. This guy. Which one do I have? I have the word population. I have this guy. So that's the one I'm going to use. Okay? This next problem says you randomly select 18 adult males and you athletes and you measure their resting heartbeat. Their sample mean, pull out your information. This is X bar. It's 64 beats per minute with a sample standard deviation of 2.5 beats per minute. Assuming that this is normally distributed, because again, my n is less than or equal less than 30. Am I going to use a T, a normal, or neither? Or a Z? Brandon, what do you think? Which one should I use? Which equation? A Z or a T? So look at the equations. Do you have this piece of information? So I should use a TC because I got this piece of information. This is the only thing you need to look at. What do I give you? So therefore, this is a TC. I'm going to use this piece. TC uses table 5, ZC uses table 4. And again, the calculator steps are nice. Z interval, T interval. Questions on this? The only thing you have to decide for yourself is which one should we use. Okay, I'm going to give you a little book assignment. And you have about a half an hour today. So you should probably get it finished in this half an hour. And then tomorrow we're going to go over it and we'll start a little review for 6.1 and 6.2. And we'll take a test on Friday. That test is going to be your last test of the marking period. Okay, there's not that many. Some of these are quick, so you're just looking them up in your table. This, I think, is just finding a margin of error. These are just putting together the intervals, and you feel free to use your calculator. Again, when you go to your calculator, you're looking at stat and test, and pull up the words that say interval. If you're a z-score, you're using the z interval. If you're a t-score, you're using the t interval. Those are the only two that we've learned so far. Z interval, T interval. They have to say the word interval in it. The Z-score for when I know the population standard deviation, a T-score for when I don't know the population standard deviation. Okay, and then you just fill in all your information. So if this is a T, it's going to ask you for the mean, the sample standard deviation, say it, SS. Even your calculator is going to tell you that. And your N and your confidence level. If you're looking at a Z, look what it asks you for, the population one. So, worst case scenario, you hit the wrong one and you look for the population, you say, I don't have that. You know you hit the wrong one. Okay? So worst case scenario, that would work.